Good morning. Myself, Bala, and we have a Julie and Dylan in there. So we did a POC on Intuit side for how we can support like a multi-cluster Argo workflow. So basically, that's a high demand in that open source community also. And when I was in that KubeCon batch processing conference, most of people are solving this multi-cluster workload in the different ways. Basically, when I was talking to like a Bloomberg people's like a Nick and all, so they give like a few suggestions. Based on the suggestions, we started looking into like how simply we can solve that Argo workflow supporting like a multi-cluster. Then basically we started with the use cases, basically based on that issue in the open source. Basically, most of the people are looking for like they want to load balance that Argo workflow execution. So they can submit that all the workflows on the one cluster, and the execution of the workflow need to be happen on the managed clusters, which is a worker clusters. And it need to be like auto load balance based on that some metrics. And another high demand on that Argo users is like they want to manage like a single UI for that multi-cluster environment. Currently, that Argo workflow UI is a single cluster UI, but the people who are running like a platforms, they have like a multiple clusters. They don't want to go to that each cluster UI to look at workflows. So when we start looking into that solution side, one thing we don't want to change that our controller to manage that all the clusters informer, which is the one Argo CD was currently designed, and currently it's not able to scaling up because when we are adding like more clusters, then the memory CPU on the workflow controller side, it will grow because it's handling like all the different clusters informer in that one controller, and it's a single point of failure also. Then when we are looking like, then we were exploring like the Kubernetes Federation project, the KubeFred V2 project, spec and everything. Then it's come out of like two product from that project is called Karmada and open source open cluster management. The Karmada is more like a push model, and open cluster is more like a pull model. The agent will talk to that hub and see that, hey, do I have any work? So I like that the open cluster, and it's a very active open source project, and currently that Red Hat is using in the production scale. So and very good support, and there's a lot of people in that community, and they're doing that. So we started like the open cluster management as the underneath for supporting like a multi-cluster one. So the main architecture of this is like as I said, the open cluster management is like a hub spoke concept. So there is a hub cluster, which is the one is like a manager kind of things. Then all the Spark cluster can join that hub cluster. Then hub cluster will distribute that load based on that lot of things, based on the label or based on the placement policy or based on that metrics. It will place that workflows into that the Spark clusters. And so
Bala,
the hub cluster,
just one quick question. Do you mind going full screen because of the resolution?
Oh,
it might be easier to read.
Are you able
Thanks.
to see that?
Yep.
Okay. So because whenever you are joining any clusters, that the hub manager is installing that agent in the hub cluster, which is the guy is mainly like a communication between like a hub and Spark clusters. This guys keep on talk to that hub cluster to see that is there any work for my cluster. Then it will automatically take that load and execute it in the cluster. So you can group it, because if you are exploring like the OCM, then OCM will support like a placement policies. There you can group that clusters for the placement, like a Linux clusters, Windows clusters, GPU clusters, all the things. Then based on that, the placement policy, the controller will place that workflow into that to that appropriate clusters. So what we did, we enhanced that our current Argo workflow controller, taking like a command line argument saying that enable multi-cluster controller. Then that controller will make sure like it won't process anything in the workflow, but it will make sure it will receive that new workflows which are created in that cluster and convert into that OCM CRD with appropriate labels, like a placement label or cluster name label. Then the OCM,
well, basically the incoming workflow, right? It has that
exactly.
label, right? It has either a cluster label or it has a label to describe which cluster set it should be placed on. Yeah.
Yeah. So then it will create it that the OCM CRD, which is called manifest work. Then after that, the OCM will take in charge of that distributing that manifest work to that appropriate cluster.
And sorry, just for clarification, so the manifest work basically, is their own CRD, and the payload that's inside there can be really any Kubernetes, CRD type, right, that you're embedding inside there. And so then, your spoke can basically pull that and then, create it on that spoke itself. Yeah.
Yeah, as Julie mentioned, like OCM is not only for Argo workflow. OCM is the common like a the multi-cluster management tool. It can support like any CRDs in that Kubernetes. Basically the manifest work is just a transporter. So when you are putting any CRD spec on the manifest work, which will distributed into that the managed clusters based on the labels. I will deep dive that the architecture. Before that, I like to show the demo. Julie is going to demo that. Then after that, I will bring back like an architecture diagram. And what is the next step? Julie?
Okay, thank you. Let's see here. Okay, so what I'm going to demo here is basically, you saw in that diagram that we had sort of these two different sets of clusters, right? There was the Linux one and then there was the Windows one. But in this, what we've done is we essentially have one cluster set, and we want to be able to do load balancing between the clusters on there. So basically, somebody would create a workflow and then specify that cluster set essentially, or it's really a placement, but kind of the same thing. And so in this case, what we're sort of doing is mimicking the idea of being able to automatically load balance using CPU availability as the metric. And the reason we're just kind of mimicking it is because it's very hard to control CPU availability. OCM basically enables you to load balance under really any criteria you want to use, although you may have to implement your own add-on to do so. But basically, this CPU availability load balancing capability is something where the spoke clusters themselves are basically reporting their CPU availability to the hub. And so what we're looking at here is basically on the left side, we've got a terminal for our hub cluster. And then on the right side, we've got two terminals for each of the spoke clusters on there, cluster 1 and cluster 2. And so on the left, basically OCM has this entity called an add-on placement score, which basically represents, the CPU availability for all of the clusters in that set. that they've reported. And so what you can see here is that basically the CPU availability for cluster 1 is 51 cores, and on cluster 2 is 70 cores. So if we go and create a workflow on the hub, obviously cluster 2 will be preferred. So we can do that. Okay, so now we should see that that's now gotten created over here on cluster 2. And there's a workflow controller that's actually running it now. And what I think wasn't mentioned yet was that Bala built an add-on on that runs on the Spoke, which is basically streaming back the workflow status in real time to the hub, and then that's actually getting incorporated in real time back to the original workflow status. So that's why we can see on the left that it shows running, and then this UI is actually running on the hub. So you've got all that workflow status basically being written in real time there. And so what is not transferring back is, things that live on the pod level itself, right? So the pod logs themselves are not being transferred back. So let's see. Okay, so then we basically fake the CPU availability here. To now make it so that cluster 1 has more availability basically. And then we can resubmit over here on the host. And so now we're going to see that that workflow has actually been sent to, or pulled really from cluster 1 and running there.
So basically the placement policy is like an optional feature which is coming with the OCM. If you don't want, then you can just have a cluster name as a label in workflow. Then the workflow controller will automatically send directly that workflow into that particular cluster.
So that placement score, the add on placement score is optional, you're saying?
Yeah, the placement score is optional. Like if you want like auto load balancing based on some availability on that each cluster, whether CPU or memory or number of workflows or number of pods, all them based on some KPI, you can do that round robin policy in that placement score.
Nice.
Yeah. Go ahead, Julie.
Okay, yeah, I mean, that's pretty much the demo there.
Yeah. Okay, let me take the screen just to give like a little bit detailed diagram to understand like what is inside. So if you go to that OCM is given like a detailed steps of like how you can enable that OCM on your multi-cluster environment. So I don't want to get into the data. Basically, here they're given for the kind, but you can have it for EKS, GCP, or anywhere. So basically, you need to install the cloud, the cluster admin and hub on the hub controller on the hub cluster. Then basically, you need to have like you need to attach the managed clusters using like a cloud admin join with your hub token, all the things. So once you join that managed cluster into the hub cluster, then hub cluster will automatically install that the clusterlet agent, which is the OCM agent on all the managed clusters to like communicate between like manage like a hub manager to the agent. Assume that if you attach like a multiple clusters, then you need to install workflow status add-on. As Julie mentioned, we wrote our new add-on, which is streaming like the managed clusters workflow status to that hub cluster. So in this way, the end customer or UI can see that workflows are executing in the hub cluster. So they won't see any difference, like because they don't want to, they don't need to get into like each managed cluster to see that workflow status, all the things. So it will automatically streaming back that all the status to that hub cluster, and the hub cluster will update the workflow status, the original workflow status. Then the UI will easily display that status with the running, completed, all the things. So if you see here, whenever that any workflows are created on the hub cluster, then the multi-cluster workflow controller will receive that and create a manifest work with that workflow payload. Then that hub manager will receive that manifest work and place that the payload to that appropriate cluster. And each Spark cluster will have like a workflow controller, which is the responsible to execute that workflow on that particular cluster. So you can see that the hub manager will create a payload on that targeted cluster, then controller will execute it. Then again that the add-on will receive the changes from a status change, and it will stream it back to that hub cluster. So what's our next step? So basically this entire changes in my personal fork, which is in because we were working as a team. So I created in my personal fork as a branch, and we were working on that. But so it's on the changes on this branch. Basically, I'm going to do two things. I'm going to add a documentation how to set up that multi-cluster environment on your side, and you can try out with our engineering build. In the meanwhile, I'm going to create a proposal on our workflow GitHub repository to get the feedback from that all the maintainer and contributor and all the users. Once the proposal is approved, then I will going to create a project plan with all the issues what need to be done in that controller side. Then probably anybody can contribute in that. That's our next step. Do you guys have any questions?
Yeah, I mean, I guess one other thing we could mention is, you know, there is that other desired use case for multi-cluster, you know, which is where you actually divide up the different pods, you know, to run on different clusters, maybe for, you know, reasons why, you know, certain pods can only run on certain clusters and that sort of thing. That, you know, is theoretically also capable through OCM, but we did figure that was a lot more work than this first set of use cases that we're handling here.
Yeah, thanks Julie to mention that. That's advanced use case because when we are talking about the multi-cluster workflow, a lot of people, they want a workflow to run on the multi-cluster entire workflow, and some of the users, they want some steps need to be run on the certain clusters. For example, the workflow contains like a few steps need to be run on the GPU cluster, few steps need to run on the CPU clusters. So that's an advanced use case, but this architecture will capable to execute it. So that also we kind of verified, but we didn't implement it because it need to have like a lot of testing and a lot of changes need to happen on the controller side. But it's still it's a very easy to implement it in that way, because instead of a pod like a workflow payload, we can just create a pod or pod payload which can execute it and return back that status. Okay. Any questions or any feedback?
This is awesome, Bala. Thank you.
Yeah. Thanks, Nick. This idea I got it from your things. When we are discussing, it's kind of you give like a hint, and I try to solutionize that one. So it will solve like most of like at least 90 to 90% of multi-cluster use cases in that open source. Some of the things like in Intuit, we have like a similar OCM, not a OCM, like we have like IKS management systems, which may not allow that OCM to interact with the multi-cluster. So we are kind of working to that IKSM team. So how we can enable that OCM on their environment. But it's very secure. I was going through that, how the hub and agent communication is happening. It's happening with a very secured way, like a token exchanging. Are you also exploring that OCM on your environment?
We've certainly considered it for a handful of different things. I think we've kind of ended up going with something a little different, or a little more proprietary, I guess. I don't know. We might open source it at some point, but if I'm sure Lewis would be happy to talk about that sometime if you're interested more.
Yeah, and one more things I like to mention. Like I was working with the OCM team to like failover.
Yeah.
If any managed clusters are like failing, they want to move the load to that what are the available clusters.
Yeah.
I think the functionality is there. The only thing we need to implement in our controller, make sure that what are the active clusters are there. If any clusters are going down, then the controller need to manage that what are the tasks are working on that particular cluster that can be moved into the current active clusters.
Yep. Yeah, that's something we're very interested in.
Yeah. I was talking to the OCM team. We can do it with the OCM API call to make sure like we need to health check that all the clusters basically.
Right.
And we need to maintain like what are the loads are running on that particular cluster. Just we need to create another manifest to move that.
Right.
One quick question I had, Bala. Maybe I missed this. What was the quick RBAC model, like the overview of that for the proof of concept right now?
So the RBAC is like mostly like it's replicating whatever things in the hub, which will be translated into that Spock also. So I think, and if you have like a separate RBACs on the Spock clusters, you can just mention the service account on the workflow, which can be, because the service accounts are mainly, RBACs are mainly used for creating a pod and executing, which is happening on the Spock side. You can set up like all the RBACs on the Spock side. The hub is like a proxy for the workflow controller. So either way is fine. Like you can have like RBACs on the hub side, which can be propagated to all the managed clusters. For example, I'm the namespace one user, and I have a certain RBACs. You can replicate that all the CRDs into all the managed clusters. the OCM has like a auto install or auto deploy manifest. So when you have that manifest, then whenever you are adding in new clusters, all the auto deploy will set up your managed clusters with all the namespace and RBACs.
Yes.
It's very flexible. The OCM is very flexible. You can do whatever things you want. You can have like a certain namespace and certain RBACs on the certain managed clusters. You can do that. Then what are the workflows with those kind of RBACs? Just go to that clusters.
Okay. So the proof of concept is inheriting the RBAC model from OCM.
Yes.
And that's
so
okay.
currently, because we are using a kind and we are using like admin permissions for everything. So currently we didn't try it out like any RBACs, like separate service account. We didn't try it, but it should work.
Yeah. Okay. So yeah, we can see the OCM documentation for their guidance on our RBAC and test that out. That's probably something we'll want the community to test out and post issues or ideas on.
Yeah.
Any other question? Check the chat. All right. Well, yeah, if no other questions, Bala, Julie, did you have any other closing thoughts?
No, I mean, yeah, there's a bunch that can still be done, you know, beyond what we did, that's for sure. But we've just cut off the first tip, I think.
Yeah. Have to start somewhere.
Yeah.
Well, thank you. Yeah, this is exciting. Let us know. I guess the next steps would be the documentation you mentioned, Bala, and then the enhancement proposal. So folks can check out probably the Argo Workflows repo for news on those.
Mm-hmm.
What do you think, Bala? Is that the spot for folks to look?
Yes.
Okay.
So I'm planning to create a proposal. Then let people will review that. And if anybody interested, reach me directly DM so that I can help you to set it up this POC on your environment. Then you can try with that the multi-cluster image.
Oh, and I do want to say, yeah, there's a particular contact that we have on the OCM side that has just been like immensely helpful. So if any of you want to talk to him directly, you know, let us know. We can give you his Slack username.
No, there is a OCM community support channel. So we can if you are facing any issues, then you can just reach out them. They're very active. Like I can see that they're immediately setting up the meeting because it's upcoming project. So they want to make it success, and they like to leverage like Argo community also. So they're doing like a lot of work on that Argo CD side. They are the contributor of like application set, and now they are doing like a pull model Argo CD. They're refactoring that Argo CD to support the pull model.
Yeah, you're right, Paul. It'd be better for them to just contact the channel, not bother one particular person. Thank you for saving him from that.
Good job not mentioning any names, Julie. All right. Well, yeah, thanks everybody for coming. We'll post the video soon. As Bala mentioned, look in the repo for updates, probably in the issues and docs. And we'll see you either at the next contributor meeting, which is in 2 weeks, or at the next community meeting next month. So yeah, Happy New Year. Catch y'all later.
Happy New Year, guys.
Thank you.